that was obtained on October 2nd by the high-rise camera on board the Mars Reconnaissance Orbiter, we are seeing the anti-tail that was pointed towards the sun, opposite to what we see in the context of comets, and now changing direction and going away from the sun, the more conventional way. We don't know what the reason is. And as you pointed out, we see some unusual composition of nickel with very little iron that we only find.
Something is moving through our solar system, and it's breaking every rule we thought we understood about comets. Right now, at this very moment, an interstellar visitor designated 3I/Atlas is exhibiting behavior that has NASA scientists scrambling for explanations. This isn't just another space rock passing through our cosmic neighborhood. This object has grown to over 1,000 times the mass of any interstellar visitor we've ever detected. And according to the latest data, it's changing direction in ways that challenge our understanding of celestial mechanics. The discovery timeline reads like something out of a science fiction thriller, except this is happening in real time. NASA's Mars Reconnaissance Orbiter, equipped with the high-rise camera system, captured the highest-resolution images of this mysterious object on October 2nd. But here's where things get interesting. Those images, the clearest views we've ever obtained of an interstellar visitor, remain unreleased to the public. NASA is holding them back. The question everyone in the astronomical community is asking is simple: why? Dr. Avi Loeb, head of the Galileo Project and director of Harvard University's Institute for Theory and Computation, has been at the forefront of analyzing this unprecedented cosmic event. His credentials speak for themselves. This is not someone prone to sensationalism or wild speculation. And yet, even he admits that what we're seeing with 3I/Atlas doesn't fit any conventional model we have for interstellar objects. The object was first detected as it entered our solar system, and from the beginning, astronomers knew they were looking at something unusual. But as more data came in, the anomalies began to multiply. This wasn't just an interstellar comet taking a predictable path through space. This was something that seemed to be actively defying our expectations at every turn.
With very little iron that we only find in industrially produced nickel alloys. And the size of the object, it's at least 1,000 times more massive than the previous interstellar objects we've seen. And the question is, why is such a giant object delivered to our inner solar system when we saw only small ones before? And it comes along the plane of the planets around the sun, and it comes close to Mars, Jupiter, and we just have to monitor it. And gladly, yesterday, the International Asteroid Warning Organization network.
Let's talk about scale, because numbers alone don't capture the sheer magnitude of what we're dealing with. When Dr. Loeb states that 3I/Atlas is at least 1,000 times more massive than previous interstellar objects we've observed, he's comparing it to Oumuamua, the first confirmed interstellar visitor detected in 2017. Oumuamua was already considered extraordinary, a cigar-shaped object that accelerated away from the sun in ways that couldn't be explained by simple outgassing. Scientists debated its nature for years. Now imagine something 1,000 times more massive making an appearance in our solar system. To put this in perspective, we're not talking about a modest increase in size. We're talking about an object so substantial that it fundamentally changes the conversation about what can traverse interstellar space and arrive intact in our cosmic backyard. The question Dr. Loeb poses is one that should give us all pause. Why is such a giant object being delivered to our solar system now? But mass isn't the only anomaly. The composition of 3I/Atlas has revealed something that makes astronomers deeply uncomfortable. Spectroscopic analysis has detected unusual materials in the object, specifically very little iron, which is strange enough for a cosmic body. But here's where it gets truly bizarre. The object appears to contain materials that we typically only find in industrial processes here on Earth. These aren't naturally occurring formations we see in asteroids or comets born in our solar system or any other stellar system we've studied. Think about what that means for a moment. We're looking at an interstellar object carrying materials that, based on our understanding of chemistry and geology, shouldn't form naturally in space. The implications are staggering, and they force us to ask questions that many scientists make uncomfortable. Is this truly a natural phenomenon we simply don't understand yet? Or are we looking at something that was manufactured? The path 3I Atlas is taking through our solar system adds another layer of mystery to an already perplexing situation. The object entered along the plane of the planets, the ecliptic plane, where Earth, Mars, Jupiter, and the other worlds orbit the Sun. This might sound unremarkable at first, but astronomers will tell you that the odds of an interstellar object randomly entering our solar system along this specific plane are extraordinarily low. It's like throwing a dart from a mile away and hitting not just the dartboard, but the bullseye. Dr. Loeb noted that the probability of this alignment happening by chance sits at approximately 0.2%. To arrive along the ecliptic plane isn't just unusual, it's so statistically improbable that it demands explanation. Natural objects entering from interstellar space should come from random directions, reflecting the chaotic nature of galactic dynamics. Yet 3I Atlas arrived precisely aligned with the planetary disk of our solar system. The object's trajectory brought it close to Mars and Jupiter, two of the largest gravitational influences in the inner and outer solar system, respectively. This close approach to major planets is significant because it provides opportunities for gravitational interaction, what spacecraft engineers call a gravitational assist or slingshot maneuver. Our own spacecraft use these techniques to change velocity and direction without expending fuel. The Pioneer and Voyager probes used Jupiter's gravity to accelerate toward the outer solar system. It's a precise, calculated maneuver that requires careful planning. And here's where the situation becomes truly unsettling. 3I Atlas was initially moving toward the Sun, as comets typically do when they enter the inner solar system. The Sun's immense gravity pulls these objects inward, they round the star, and then swing back out into space. It's predictable, it's understood, it's what comets do. Except 3I Atlas changed direction. The object is now moving away from the Sun in what Dr. Loeb describes as the more conventional way for a comet post-perihelion. But the timing and nature of this directional change is what has scientists puzzled. Was this simply a natural gravitational response to its trajectory, or did something else influence this course correction?
And, that would be a great blessing, irrespective of whether it's natural or technological. But if it happens to do a maneuver when it comes close to the Sun, the way spacecraft do, using gravitational assist from the Sun, that would definitely affect the markets, the financial markets, and politics on Earth.
Why? Because everybody will suddenly feel like, uh-oh, we've just been invaded? I mean...
The astronomical community is taking this situation seriously enough that unprecedented coordination is now underway. The International Asteroid Warning Network, a global organization responsible for detecting and characterizing potentially hazardous near-Earth objects, has initiated something remarkable. They've organized a coordinated observation campaign spanning 2 months, from November 27th through January 27th. This campaign will utilize every available asset, both ground-based telescopes on Earth and space-based observatories, to gather as much data as possible about this mysterious visitor. This level of international coordination is rare. It signals that behind closed doors, away from public statements and press releases, scientists are deeply concerned about what 3I Atlas represents. They're mobilizing resources on a scale typically reserved for potentially hazardous asteroids on collision courses with Earth. But 3I Atlas isn't on a collision course, so why the urgency? What are they really looking for? Dr. Loeb's Galileo project has taken its own proactive stance. They've dedicated 3 observatories to continuously monitor the sky for any unusual activity in the coming months. They're not just watching 3I Atlas, they're looking for anything else that might accompany it. Because here's a possibility that few scientists will state publicly, but many are considering privately. What if 3I Atlas isn't traveling alone? The concept Dr. Loeb introduces is particularly intriguing and unsettling. He raises the possibility of a mothership scenario, an object that could release smaller probes capable of independent maneuvering. This isn't wild speculation. It's a logical extension of how we ourselves explore space. When we send missions to other planets, we often use a larger carrier spacecraft that deploys smaller landers, rovers, or probes. If an intelligence wanted to explore our solar system, this would be an efficient approach. One large vessel making the interstellar journey, carrying numerous smaller explorers to investigate different targets once it arrives. The Galileo project isn't just watching through telescopes. They have observers on Mars, the various rovers and orbiters we've stationed there over decades of exploration. These assets can now serve a dual purpose, continuing their primary scientific missions while also monitoring for any unusual activity that might be connected to 3I Atlas. If something deploys from this object, if smaller craft begin maneuvering in ways that defy natural explanation, we'll have multiple vantage points to document it.
Affect the markets, the financial markets, and politics on Earth.
Why? Because everybody will suddenly feel like, uh-oh, we've just been invaded? I mean, because if it doesn't maneuver around the sun, that would show it's not a natural object, right?
Yes, it will be a technological signature, but it could be also a mothership that releases mini probes that maneuver. And so I tasked the research team of the Galileo project.
Perhaps the most provocative scenario Dr. Loeb discusses is what would happen if 3I, or Atlas, performs a deliberate gravitational assist maneuver around the sun. This is where science meets speculation in the most dramatic way possible. A gravitational assist is a sophisticated maneuver. It requires precise calculation of velocity, angle, and timing. Natural objects don't decide to perform gravity assists. They simply follow the laws of physics based on their trajectory and velocity. But spacecraft do. Every interplanetary probe we've launched that ventured beyond the inner solar system has used gravity assists. It's a hallmark of intelligent navigation through space. If 3I Atlas executes a maneuver that clearly demonstrates intentional use of the sun's gravity to alter its course in a way that doesn't match natural orbital mechanics, that would constitute proof. Not evidence, not a hint, not a suggestion. Actual proof that this object is under intelligent control. Dr. Loeb's observation about how this would impact humanity is particularly striking. He suggests it would shake financial markets, create global upheaval, force us to confront the reality that we are not alone in the universe. And he's absolutely right. The confirmation of extraterrestrial intelligence wouldn't just be a scientific discovery, it would be a civilizational turning point. Every assumption we hold about our place in the cosmos, our uniqueness, our future, would instantly require re-evaluation. The language he uses is careful but clear. If the object performs such a maneuver, that would show it's not a natural object. In the scientific community, this is as close to a definitive statement as you can get about such an extraordinary possibility. He's not saying it's likely. He's not claiming to know what 3I Atlas is, but he's stating plainly that if certain behaviors are observed, they would eliminate natural explanations. Dr. Loeb introduces a concept that should make us all pay very close attention: the black swan event. This is a term from risk analysis, referring to an event that comes as a surprise, has a major effect, and is often inappropriately rationalized after the fact with the benefit of hindsight. He suggests that 3I Atlas could be a Trojan horse, something that appears benign but carries implications far beyond what's visible on the surface. Think about the original Trojan horse from ancient history. The Greeks laid siege to Troy for 10 years without success. Then they constructed a massive wooden horse, hid soldiers inside, and presented it as a gift. The Trojans, believing the war was over and the Greeks had departed, brought the horse inside their walls. That night, the hidden soldiers emerged and opened the city gates for the Greek army. Now consider 3I Atlas in this context. It appears to be a comet, perhaps unusual, but still within the realm of natural phenomena. It approaches our solar system, draws close to major planets, and then continues on its way. But what if there's more to it? What if the object we're tracking is the horse, and the real significance lies in what it might be carrying, or what it might be doing while we focus on its visible presence? This isn't paranoia, it's prudent scientific caution. We must take seriously any object that exhibits this many anomalies: the unusual composition, the implausible trajectory, the massive size, the directional changes. Individually, each might have a natural explanation, but collectively they form a pattern that demands we keep every possibility on the table, no matter how uncomfortable those possibilities might make us. The level of institutional interest in 3I Atlas reveals just how seriously officials are taking this situation. Dr. Loeb mentions being invited to Washington, D.C. to brief members of Congress. This isn't standard procedure for astronomical discoveries. Congressional briefings are typically reserved for matters of national security, policy implications, or events that could directly impact the nation and its citizens. What does Congress need to know about an interstellar comet? What briefings are happening behind closed doors? The public statements we hear are carefully measured, designed to inform without causing panic. But those private briefings likely contain more detailed analysis, more frank discussion of the anomalies, and more serious consideration of scenarios that sound like science fiction. Public interest has reached extraordinary levels. Dr. Loeb mentions upcoming appearances, including a podcast with Joe Rogan, one of the most listened-to platforms in the world. This represents a recognition that the scientific community cannot keep this conversation locked in academic journals and astronomy conferences. People want to know what's happening above their heads. They want to understand what this object is and what it might mean. The challenge, as Dr. Loeb notes, is misinformation. In an age where speculation can spread faster than facts, where conspiracy theories gain traction before official explanations can be formulated, scientists face a difficult balance. They must be honest about uncertainty while combating wild claims. They must acknowledge the extraordinary possibilities while not overstating the current evidence. Here's what makes this entire situation so immediate and pressing. 3I Atlas will make its closest approach to Earth on December 19, 2025. That's not some distant future date. We're talking about an event that's approaching rapidly on our calendar. By mid-December, this object will be at its nearest point to our planet during its transit through our solar system. Dr. Loeb frames this with a clever metaphor: an interstellar blind date. We didn't ask for this visitor. We didn't know it was coming until it was already here. And now we have a limited window to learn everything we can before it continues on its journey into the depths of space. Once 3I Atlas leaves our solar system, it could be centuries or millennia before we encounter another interstellar visitor with this kind of accessibility. The December 19th date creates both opportunity and urgency. every major telescope, every capable observatory, every space-based instrument will be focused on this object during its closest approach. The data we gather in that window could answer fundamental questions about its nature, composition, and behavior. Or it could deepen the mystery even further. Think about what we're hoping to learn. Is this object responding to solar radiation in ways consistent with natural outgassing? Are there thermal signatures that match known cometary behavior? Does it exhibit any activity that suggests internal energy sources or systems? Will it maintain its current trajectory, or will there be additional course corrections that can't be explained by gravitational forces alone?
The conversation takes a darker turn when the notion of a serial killer is introduced, a grim metaphor for the possibility that not all first contacts would be friendly. This is the question that lurks beneath all discussions of extraterrestrial intelligence. If we're not alone, if another civilization has developed the technology to cross interstellar space, what are their intentions? Dr. Loeb doesn't dismiss this concern, but his response reveals a fascinating perspective. He seems to suggest that we must proceed with both caution and openness. The alternative, ignoring the evidence, refusing to investigate, pretending that anomalous objects are simply misunderstood natural phenomena, that path leads nowhere. Humanity has always progressed by confronting the unknown, by asking difficult questions, by following the evidence wherever it leads. Science, as he points out, should be guided by evidence, not by preconceptions about what we want to find or what makes us comfortable. If 3I/Atlas is a natural object with a bizarre but ultimately explicable set of characteristics, then studying it will expand our understanding of comets, interstellar objects, and the dynamics of our galaxy. We'll learn something valuable about the universe. But if it's something else, if it represents our first clear evidence of extraterrestrial technology, then we're standing at a threshold moment in human history. Everything changes. Not immediately, perhaps not dramatically in our daily lives at first, but philosophically, scientifically, culturally, we would be forever transformed by the knowledge that we are not the only intelligence in the cosmos. The Coordinated Observation Campaign beginning November 27th represents humanity's best effort to understand this visitor before it slips away. Ground-based telescopes across the globe will track its position and movement with unprecedented precision. Space-based observatories, free from atmospheric interference, will capture spectroscopic data revealing its chemical composition in detail. Radio telescopes will listen for any electromagnetic emissions that might suggest artificial origins. The Mars-based assets provide a unique advantage. Our rovers and orbiters were designed to study Mars, but they can also serve as outposts watching for unusual activity in the inner solar system. If 3I/Atlas does something unexpected, if it releases smaller objects, if it alters course in ways that defy natural explanation, we'll have multiple perspectives documenting the event. Every major space agency is involved. NASA, ESA, JAXA, and others are coordinating their observations and data sharing. This is international science at its finest, nations setting aside differences to pursue knowledge about something that affects all of humanity equally. Whatever 3I/Atlas turns out to be, the answer matters to everyone on Earth. The Galileo project's role in this effort cannot be overstated. While institutional astronomy sometimes moves slowly, bound by committee decisions and funding cycles, the Galileo project represents a more agile approach. They're specifically looking for evidence of extraterrestrial technology, and they're not afraid to state that mission clearly. This gives them freedom to investigate possibilities that more traditional institutions might avoid for fear of ridicule or controversy. Dr. Loeb makes a crucial point about attracting young people to science. In an era where STEM education faces challenges, where careers in research compete with more immediately lucrative paths, something like 3i/Atlas can ignite imagination in ways that textbooks cannot. A mysterious object from beyond our solar system, exhibiting behaviors that challenge our understanding, potentially carrying implications for humanity's place in the universe. This is science that matters, that excites, that demands attention. The findings we obtain in the coming months could indeed be very significant. This isn't hyperbole or dramatic overstatement. If we confirm that 3i/Atlas is simply an unusual but ultimately explicable set of characteristics, then we'll still have learned something valuable about the diversity of objects that traverse interstellar space. We'll have data to inform our models of planetary system formation, comet composition, and galactic dynamics. But if it's something else, if it represents our first clear evidence of extraterrestrial technology, then we're standing at a revelation that will ripple through every aspect of human civilization. Religion, philosophy, politics, science, art, culture, nothing remains untouched by the knowledge that intelligence exists beyond Earth and has the capability to reach across the vast distances between stars. We stand at a unique moment in history. Above our heads, moving through the darkness of space, an object from another stellar system is approaching Earth. In just a few weeks, it will be closer to us than it will ever be again. Telescopes around the world and in orbit are turning toward it, capturing every photon of reflected sunlight, analyzing every spectral signature, tracking every subtle change in trajectory. The scientists studying 3i/Atlas are not sensationalists. They're not seeking attention or promoting wild theories. They're following rigorous scientific methodology, gathering data, testing hypotheses, and remaining open to whatever the evidence reveals. But they're also honest enough to admit that this object doesn't behave like anything we've seen before. The questions raised by 3i/Atlas are profound. Why is something so massive traveling through our solar system? Why does it contain materials we associate with industrial processes? Why did it arrive along the ecliptic plane against astronomical odds? Why is it changing direction in ways that demand explanation? We don't know yet, but we will know more soon. The observation campaign will gather unprecedented data. The December 19th close approach will provide our best opportunity to understand what we're dealing with. And whatever we learn, however the evidence ultimately resolves, humanity will have asked the right questions and sought answers with scientific rigor and intellectual honesty. As Dr. Loeb notes, this is an interstellar blind date. We're meeting a visitor from beyond our cosmic neighborhood, learning about it in real time, trying to understand its nature and significance. Most blind dates lead nowhere particularly meaningful, but sometimes, rarely, a blind date changes everything. By December 19th, we'll know more about our visitor. We'll have data to support or refute the various theories. We'll be able to speak with greater certainty about what 3i/Atlas truly is. Until then, we watch, we measure, we analyze, and we prepare ourselves for whatever the evidence reveals. The universe is vast beyond human comprehension. Our galaxy alone contains hundreds of billions of stars, many with their own planetary systems. The idea that Earth hosts the only intelligence in this cosmic ocean has always seemed statistically improbable. Perhaps 3i/Atlas is simply a rock, a frozen remnant from another stellar system, tumbling through space on a trajectory that happened to bring it near our sun. Or perhaps it's something more. Perhaps we're witnessing the first clear evidence that we are not alone, that somewhere out there, under alien skies orbiting distant stars, another intelligence looked up at the cosmos and decided to explore it. And perhaps, whether by design or by chance, their exploration has brought them here. The coming weeks will tell us more. The instruments are ready, the observers are watching, the data will arrive, and soon we will know if we are witnessing a natural wonder from the depths of space, or if we are experiencing first contact with something far beyond our current imagination. The universe is revealing its secrets. We need only have the courage to look, to question, and to accept whatever truth emerges from the darkness between the stars.